Mercury is a natural element and a well-known pollutant that occurs in different forms in our environment. Different man-made pressures have led to changes in the biogeochemical cycling of mercury in the environment. These pressures include anthropogenic emissions from the burning of fossil fuels, artisanal gold mining, and insufficient wastewater treatment, as well as changes in climate and land use. Mercury can be transported over long distances in the atmosphere, meaning that local emissions can become a global problem. Microbes can transform mercury into methylmercury, a neurotoxin of special health concern. Once it enters the human body, it can lead to neurological problems, especially in small children. The main pathway of methylmercury exposure to humans is via the consumption of seafood. To reduce human exposure to mercury and protect the environment, 137 countries have signed the Minamata Convention on Mercury since 2017. In the GMOS-TRAIN project, 15 PhD students work at 9 institutions all over Europe and with worldwide collaborations. We aim to fill key knowledge gaps on the environmental cycling on mercury and to forecast the environmental fate of mercury on a regional to global scale. With the GMOS-TRAIN network, we aim to support the Minamata Convention by bridging science, societal needs, and policy making. Atmospheric mercury can interact with vegetation when binding to organic material. This can make it available for consumption. Mercury can also be incorporated into the soil or transported to freshwater lakes and reservoirs by organic matter. Litterfall is one of the main pathways of atmospheric mercury to terrestrial pools, and many aspects of this intercompartmental exchange are unknown. In Arctic regions, historical vegetation uptake and storage of mercury since the last ice age have led to high mercury concentrations in permafrost soils. Climate change and Arctic warming could disrupt this mercury storage, possibly forming methylmercury hotspots and releasing mercury back into the atmosphere. In GMOS-TRAIN, we are investigating the risk posed by remobilized terrestrial mercury emerging from thawing permafrost. In the marine environment, the neurotoxin methylmercury can be taken up and biomagnified in the food chains. This can lead to methylmercury concentrations in large fish, seabirds, and marine mammals that are of concern for both humans and wildlife. To better understand the complex physical and biogeochemical processes that determine the fate of mercury in the marine environment, we combine a large variety of different measurements in the ocean and its interfaces with the atmosphere, coastlines, and sediments. By improving our understanding of the environmental fate and dynamics of mercury, GMOS-TRAIN will improve mercury models on a regional and global scale. This will help policymakers to design and implement effective environmental strategies to safeguard seafood across the globe.